This webinar is being recorded, and the recording and the slides will be available on the Genesis Customer Care portal within a week after the webinar. You'll receive an email with a link where you can view the recording or download it. And for recording quality, all phone lines have been muted during the presentation. If you'd like to ask a question while our presenters are speaking today, you can type your question into the question chat window on the control panel for the webinar, or you can click the hand icon next to your name in the attendee list. We will not answer questions by voice until the end of the webinar. However, we will attempt to answer questions that are typed into the question chat window all during the webinar, and we'll answer any that require a longer explanation at the end. When you exit the webinar today, you will be given a 3-question quick survey. We hope that you'll take a moment to fill out that survey because it helps us to plan the topics for future tutorials. Today's presenters are Vish Kosher-Lakota and Oleg Filipenko. And I would like to now turn over the webinar to Vish. Thank you.
Thank you, Debbie. Welcome all. Thank you so much for joining us. My name is Vish, and along with me, my colleague Oleg. So we are going to present this tech tutorial 81, and this is about troubleshooting SIP server issues. And we are concentrating on the topics briefly about Genesis SIP server, SIP and associated VoIP protocols, and then understanding parts of a call, media services, and the more concentration we are putting on what can affect a call flow, then SIP server, how it identifies source and origination DN, and then selection of destination DN. Next to that, we will see how SIP and TLAB messages they are printed in the logs and how to understand them. Then we'll move on to multi-site calls. Next, high availability and SIP span tool. So let's start with Genesis SIP server. As we know, it's a SIP server. It's a combination of T server and a call switching component. And this call switching component acts as a SIP back-to-back user agent. And usually we denote it as B2B UA, back-to-back user agent. And the first important point is SIP server provides both SIP signaling as well as it can act as a T server. Means you cannot connect to any other switch, but it can act as a T server itself, and it can provide all the functionalities which are done by T server, that is via T server common part. And the next one is for the Genesis, for the media capabilities. You can use Genesis Media Server or Stream Manager, and these components, they provide announcements, music on hold, multi-conferencing service, and similarly you got CPD capability, and you got many other media capabilities which the latest Genesis Media Server can provide. Next one is it's the SIP message that SIP server send or receive. They are very similar in most of the configurations, and the destination selection, it depends purely on the deployed configuration. So depending on the options you configure, so it's going to select the destination and it's going to send the SIP requests. This mostly applies to the routing of invite messages and other messages which are within the dialog, they just follow the path established by invite. In the slides, I will try to mention a couple of documents or other tech tutorials which were already given, so that you can actually use them to understand more clearly, like you can dig deeper into the investigation part, which may help you. And at this stage, where you can use Genesis Events and Models reference manual. So that contains all the TLib call flows given in that, different call models. It can be inbound, outbound, call transfers, conference. In these type of call models, how exactly TLib events are generated, what events generated, where they are, like is it on the source DN, destination DN, consulted party. So that information is given in this document. You can refer that. Now, looking SIP server in the contact center environment, you may be having a very complex environment, but I just taken a very simple basic one where you have Genesis suite, and other side for connecting the customer calls, you got your external network, and that is connected to a media gateway, and then you got SPC, media gateway or SPC we can call it as, and these components will communicate via SIP to SIP server. And then you got Genesis suite here, wherein management framework, your agent desktops, URS stat server, you got many Genesis components. So depending on the protocol they use, either they communicate on TLib protocol or they can communicate on SIP protocol. For example, you take GVP, RM, and MCP, they communicate via SIP, and SIP endpoint that again communicates via SIP, and SIP server, as we discussed in the previous presentation, previous slide, it's the combination of TLib, T server common part, and you got SIP and STP here. And starting from the beginning of this presentation, we always say it's the RTP that flows between the endpoints only. SIP server will not involve in the RTP traffic. And same case when you are talking to endpoint, SIP endpoint, this is one user agent, and you got SPC or media gateways as another user agent, and the RTP flows directly between them. It is very useful when you are investigating issues like silent calls, or there is a jabber, or there is some noise in the voice traffic, voice quality. All those things you need to concentrate more on RTP traffic level. Definitely we need to make sure SIP signaling is proper, is perfect, and once that confirmation is done, then you will go to the RTP side investigation. We will see how we are going to do that in the next slides. Very briefly about the SIP and associated VoIP protocols. For any voice over IP communication, we use SIP. Particularly, I'm talking in the sense of Genesis SIP server. Now you got the SIP protocol. SIP protocol, session initiation protocol. This is a signaling communication protocol, and this is the one used for establishing the connection between two end devices. And then you got the STP. Remember that STP is describing the streaming media only, and it is not actually sending any media. It's only acting as a media initialization parameter content. So codec negotiation, RTP IP address, and RTP port, all these details are placed in STP. And the real-time transport protocol, this is the foundation for everything. This is the protocol which actually sends and receives the voice traffic between the endpoints. And RTP uses real-time control protocol along with this. And RTP carries media streams, and RTCP is used for monitor transmission statistics and quality of service. And this also aids in synchronization of multiple streams. Let's see how Genesis SIP server is going to use this, and what happens in the investigation. Now, understanding parts of the call. As SIP server is having two parts. One is the SIP layer, and you got T-library layer. So the main the main signaling is based on SIP. So you need to be aware of SIP protocol and the messages they are exchanged, everything. You can refer RFC 3261 for this, and that gives the guidelines for the headers or the SIP protocol content itself. Okay. Now coming to for our investigation part. Now when you see a SIP session, SIP message, you will see the top line indicating either a request or it's a response or a provisional response. Status line it gives, and then the blue color ones, they represent SIP headers. Just for this presentation point of view, you got via header, max forwards, contact, to, from, call ID, C sequence. So to understand what these are and what the guidelines required for these headers, you need to refer RFC 3261. For us, for investigation point of view, you need to understand the concept of SIP dialog. SIP dialog is identified by call ID, a local tag, and a remote tag. Call ID is this one. This is the unique identification given to any SIP message. And then you got the from tag. The device which is initiating the SIP message, it's going to add a tag in the from header, and it will not keep anything in the to header. When the other party, when it responds to this request, that is going to keep the tag, and that is treated as a remote tag. So note that 100 trying will not keep any two tag. Starting from the 180 ringing, 183 session progress, these provisional responses, they will have the two tag, and that's where we say it as SIP dialog established. Note that it's not call establishing, it's the dialog established, and within the dialog you will have all the rest of the messages flowing. And your SIP message may contain STP, session description protocol. This talks about media, and this here the example, it shows that RTP destination, the voice traffic source is 192.168.0.3, and it's a audio communication. It's a audio communication, and 5082 is the port number, and you got the list of codec order is given here. We call it as preference codec order. This device, it started with 125.9.8. This is the preference codec order, and the destination device, which is receiving this invite and responding to this invite, that device can select any of these codecs and it can respond back depending on its common codec selection, we call it as. Everything is configurable, but note that STP part, we have little bit of manipulation we can do in the SIP server point of view. However, most of the times we will keep as it is, and we will send purely depends on business requirement. Now, if you see a SIP-based VoIP call between endpoints, it's UA is user agent. So this is the terminology we use in RFC. Throughout the RFC, you will hear user agent 1 and user agent 2, two user agents, and that's where you get back-to-back user agent also. And now here user agent 1 sent an invite with STP offer. So STP offer stands for, this is the message which contains the STP, and it tells this is the RTP IP and port you can reach me on, and it will tell what codec this UA1 supports. And upon receiving this, the phone ringing, 180 ringing message. Then this user agent 2 is going to respond back with 200 OK and STP answer is there. And once the codec negotiation done, user agent 1 sending acknowledgement, and then you got the RTP traffic flowing between the endpoints. So any of the party can terminate the call. They are happy. So by 200 OK, they disconnected the call. That's fine. This is normal, a basic call flow between two SIP endpoints. Now when we move to the Genesis SIP server, let's see. A VoIP call with the Genesis SIP server in call flow. So as we know, SIP server is going to act as back-to-back user agent. It will create two separate SIP dialogues. Suppose if the customer is coming from here, media gateway connected to media gateway and media gateway initiating an invite. You got the SIP dialogue as told previously. A SIP dialogue means it will have a unique call ID. From header contains a local tag and to header contains the remote tag. So they represent the SIP dialogue. And Genesis SIP server receives that invite and it's going to start processing. Call may be on the root point or call can directly go to agent endpoint. No problem at all. It's going to initiate a new dialogue. So a new call ID, a new from header and a new. So it won't keep the two remote tag, but agent endpoint is going to keep the two tag. Now, make a note of it. So once the connectivity is done, once the SIP signaling is perfect, you will have the RTP traffic flowing between the endpoints directly. Okay. So I try to put this information in schematic diagram. You have the back-to-back user agent. Daily part we will see in the next slide. User agent 1 is sending invite with STP offer, and this is denoted in SIP dialog 1. Genesis SIP server, it process and create a new dialog and send the invite. And once you receive the 180 ringing, SIP server is going to send 180 ringing. My bad, I'm clicking the pointer more often. So 200 OK with STP answer. Then you got the then SIP server sending 200 OK with STP answer. Acknowledgement received, then acknowledgement sent to user agent to the side. Again, RTP traffic established between the endpoints directly. And any party can disconnect the call. And here we decided let the caller disconnect the call first. So caller disconnected, you receive the bye message, and SIP server is going to terminate the other dialog also. The reason to put this SIP dialog information again and again is during investigation, when you are investigating any SIP server call flow with the SIP server in middle, you need to note which side you are checking. Like you need to make a note of the dialogues, call ID of each leg, so customer side, and similarly you got agent side. So once you make a note of it, you can follow all the SIP messaging happening in the dialog, and you can find out root cause of the problem. Then in the TLIP part, so depending on what is happening behind the in the SIP layer, SIP servers keep sending information or the call events to TLIP clients which subscribe for those DNs, like event ringing, event off hook, event established, and when the call terminated, event released. All these events, not only these events, suppose if the invite is coming for a root point, so it's going to send event queued and event root request to URS. So it's the TLIP part is going to be on top of SIP layer, and depending on what message you receive, it's going to process the call. This is the way actually Genesis SIP server functions. Let's dig deeper. Media services, whether it is a single site environment or a multi-site environment, Genesis GVP RM and MCP, they are going to provide the media server capabilities, media server services. You can use Stream Manager also. no problem with that. And there it uses NetAN announcements. For all media services, only one MSML DN can be used. It's a MSML support equal to true, and if you have the recording, you will set MSML record support equal to true. These options you set on the SIP server level, and then you configure the MSML DN. For all media services, you configure only one DN, MSML DN. But note that if it is for a CPD, you are going to create a trunk group DN, and you are going to point it towards RM and MCP. So that will follow the trunk group DN path. And GVP troubleshooting, it was in detail covered in Tech Tutorial 74, Troubleshooting Best Practices for GVP 8.x. So you can refer that one. Now, here is the slide where we can start digging deeper into our log sections and options. What can affect a call flow? Any SIP message or any TLib request which arrives to SIP server, how it decides or what type of processing to start on that particular call, it depends on what options you configured on the SIP server application level. You got the SIP address. Several SIP application level options are there. So throughout the call, so it depends on what options you configured on the SIP server level. So they will affect the call flow. They will influence it, and DN level properties also, DN level options, they are also going to affect the call flow. Now, if you see here, you got media services provided by Genesis Media Server. You got the MSML DN, and you got inbound trunk. A customer is connected via a trunk DN, media gateway, or SPC, or any third-party IPPBX. Most of the times you connect using the trunk only. If it is for the agents, you can use soft switch. We will see how SIP server decides whether it is a trunk or soft switch in the later slides. And similarly, you got an extension DN, and you can see several DNs we created here, and each DN is meant for providing one or the other type of functionality as per business requirement, we can call it as. This is for my lab requirement. So if you take a, I'm sorry if you are hearing any noise. If you see an example of a simple inbound call connected between customer and agent, it will have two DNs representing both parties. If it is an internal call, two extension DNs, they will be there. Or if it is connected via trunk DN, it is coming from a media gateway. You got the media gateway trunk DN and agent extension. So the options, whatever you configured on this, they are going to have effect on your ultimate call flow. And similarly, if you have any issue when you are investigating, you will depend more on the what type of call flow it is, where the problem, what are the symptoms, and you need to make sure you understand what DNs participated in the call flow. So accordingly, you are going to investigate, taking the DN configuration options, similarly SIP server configuration options. So collaboratively, you are going to decide on what could have happened in the call flow that resulted in any type of symptom. So again, I took the same example what I told previously. Two user agents connected via Genesis SIP server. There could be a chance there is some problem on the network, or problem at caller side, a media gateway not working, a network failed, any type of problem. You will see something like the response 200 OK STP response coming from user agent 2, but the 200 OK is not reaching, and you can see the 200 OK STP answer. These are keep on coming up in intervals up to 32 seconds. We keep on receiving 200 OK with STP, and same thing, it's going to send it to media gateway, but no response. And then either endpoint can maybe disconnecting the call, or SIP server can disconnect call after timeout. That's why we put as decision on call termination. Any of the party can decide on what it is. And you can see by we sent it, but there is no network here. So however, SIP server point of view, when it sends by the call terminated, it will not wait for the 200 OK. Okay, 200 OK if we receive, fine. But some unforeseen or unfortunate scenarios, we don't receive 200 OK. But for Genesis SIP server, the call is terminated or released. Now if you see same thing, problem maybe at the agent side, you got the user agent 2. After sending 200 OK with the STP answer, so media gateway received it and it sent acknowledgement, SIP server sends acknowledgement, but user agent 2 never received it. The problem what happens is, most of the scenarios here, because already 200 OK STP offer answer exchange, there could be a chance that you will have a silent call here. Okay, sometimes that happens. But again, Genesis SIP server or caller, one of them is going to decide call termination. It can be usually like a customer, if he is not able to hear any agent, and if he just says hello, hello, he may be disconnecting the call. That time media gateway sends bye on the dialog one, and SIP server sends bye to the destination. Again, as I said, you may not be receiving the 200 OK. However, as we send the bye, SIP server clears the call. Okay. So on network and end devices issues, you can go through the Wireshark traces. You have a couple of tech tutorials within our Genesis knowledge base, where they provide how to capture information in Wireshark traces. You can follow that and you will get that information coming. Identifying source or origination DN. Let's see. When SIP server receive an invite, it need to decide or it need to associate that invite to any of the DNs which are in the configuration management database. Reason is, if you have geolocation such options configured, so it can decide on media services and other type of services will be selected depending on your geolocation. And the procedure it follows is, we will see here. Ladies and gentlemen, just one request. I'm in India now, and we have a festival of firecrackers, Diwali we call it as, and occasionally you may be hearing some noises, loud noises regarding this. So people are enjoying the firecrackers, so I apologize for the inconvenience, but it's just occasionally you will have. So tomorrow is the grand celebration, so today only teasers or testers, they are trying it. Okay, now moving on to slide now. Okay, who sent invite? Now when SIP server receives an invite, first it will check for the username in the from header or contact header, and it will try to verify if there is any internal extension DN in the configuration management database. If it finds a extension DN, so it is associated with that extension DN, and it will process the call. From there. That means it knows where the call is coming from. If not, if there is no matching in any of the internal database with the number coming in from our contact header, then it goes and checks if the IP address from the via header of the incoming invite message matches with any host address configured in the trunk DNs. And before going to the last note, let's see how it is. Now, I received an inbound from an agent, inbound invite. So it decides source DN. Now, if the username in the from or contact header of the incoming invite match the name of an internal extension DN, Now, from header, it has 2221, and similarly contact also 2221, and it checks for the configuration management database. So any number matching to this, now note that any number matches to the extension DNs. So I have 3 extension DNs here, and yes, of course, it is matching with 2221. As it finds the extension, so it decides, okay, the caller is 2221, then 2223, of course, it's the selection of destination DN, it's an extension DN, and if it finds the contact address, it's going to send the invite to that contact. So as it is between 2 extensions, it reported attribute call type equal to 1. That means it's an internal call. So it generates event off hook and event dialing, and the call is processed further. Now, suppose if the invite is coming from an external party, so it doesn't know where from it is coming. Now, to decide or to associate any of the trunk DNs, let's see. Now, from header has got 9819276249, one number, and it try to find, yeah, it cannot find. But note that here there is a disabled trunk with the name 9819276249, but this is a trunk DN and it will not associate with this one. Anyway, it's disabled. So there is no extension DN with this number. So it will try to find, is there any trunk that has the contact address? So contact address via header. Okay, let me add now contact header, from header. So there is no match. Now let's see in the via header 192.168.0.3. Yeah. So there is the inbound trunk, and here the contact is 192.168.0.3, and it is matched to the contact address. Checks if the IP address from the via header of the incoming invite message match with the host address of the contact option of trunk DNs. Yes, it matched. So in the log files you can see this line that is representing gateway inbound trunk associated with address 192.168.0.3. So this is the way, like if I find something when SIP server receives the invite, it depends on 3 parts: from, contact, and via. So if there is no match extension DN, then it will try to look in the trunks. If there is a case where I received an invite from an unknown gateway, we have an option to allow the calls from unknown gateway, so they are also allowed. Now, as previously, let's go back. So the invite is coming on number 9001. So it's going to send the call to a root point. You got the event queued and event root request, and the call is processed as per the strategy loaded on the root point. Fine. Let's move on to the selection of destination. Just a moment. Let's go back. Now coming to this note about the option enforce external domain. So when this option is configured, most of the times in BCP, business continuity plan, or when you got multi-site environment, you will configure this enforce external domain, and it will add all the SIP gateways or hosts which are external to that particular SIP server. Suppose if you are configuring on SIP server 1, you will keep other site SIP server as well as media gateway addresses as external parties, so that there will not be any misunderstanding from the SIP server that it is an internal call. And this is a vital option when you are configuring business continuity plan. Okay, so that's the reason I mentioned this note at this place. Okay, now move on to the next ones. Selection of destination device. When a call is routed to an extension, SIP server need a contact address to initiate SIP dialog. Now we receive an inbound invite, call may be placed on a route point and then it finds a target agent, or call may be directly going to agent, or call may be external to the SIP server, can be anything. But if you see the procedure SIP server follows is, when it gets the target information, can be anything. First it checks if I have any SIP registration available. If there is a SIP registration, it's going to send a new SIP dialog or the new invite on that particular IP address. If there is no registration available, and it checks for the contact option in the matching extension DN. If there is a contact option mentioned and there is a static entry, this is very important. If there is a static entry, it's going to send invite to that particular IP address and port. There is a matching extension available, but there is no contract address available, there is no SIP registration available, then SIP server will check for a soft switch DN. If that is available, it's going to send a new SIP dialog to soft switch. One important point, in case you do not have a soft switch DN, then call will be failed. Okay, so make sure if you have a third-party PBX and all the agents are connected to that third-party PBX, so you can simply configure a soft switch DN and you can leave the contact address, just specify contact and keep it null or star. So SIP server is going to send the call to soft switch DN. Okay, and the last one, and it's a very powerful one, if there is no matching extension DN, if there is no matching extension DN, then it will try to route it to a trunk DN. Trunk selection, again, it will be made depending on working with multiple devices feature. That means you got geolocation, you got prefix, you got several options are there, which will narrow down the trunk selection to a best one. So best route we call it as. So the best destination is selected following the feature working with multiple devices. So you can follow this multiple devices selection feature, and you can understand various methodologies it will follow to select a destination DN. Now, selecting extension DN, when a call is routed and destination number matched to an extension DN in CME. So it finds, yes, I got a static entry here and I got the extension DN. So it's going to send new invite to this particular IP address. Now, if there is no entry there, but there is a thing, register message received from the DN and the contact address given is 2221 @ IP address, and you got all the additional parameters, and SIP server stores that information depending on registrar persistent equal to true or not. So if it is true, it will update configuration management database, otherwise it will keep in memory and it's going to send new calls to this IP address. So 200, okay. It's going to send, if target agent is 2221, so it's going to send invite to 192.168.0.2 at port number 9840. Now selection of the soft switch, if there is no value specified in contact option of extension DN, SIP and SIP endpoint representing DN does not register with SIP server, then SIP server checks for any soft switch service DN. That's what discussed previously. What is a soft switch DN? This is a device that is represented under a voice over IP service DN. You will create a voice over IP service DN, and the service type you will keep it as soft switch. Sorry, a long one. Service type you will set it as soft switch. And trunk, of course, you will have destination number does not match with any internal DNs. Then SIP server will try to look for a trunk DN to initiate a new SIP dialog. Again, trunk selection will be made as per the guidelines given in working with multiple devices. Now let's move on to understanding SIP server logs. Okay. Now, when you open SIP server log, the first log file after you restarted the SIP server, that is the startup log. This is vital for most of the cases investigation. If you have several type of call flows affected and you need to troubleshoot, to understand what DN configuration SIP server read, all those details are available in the startup log. And customer care point of view, we request this log file often. So let's see. The top one is the application name, so what you configured, and then application type, and command line parameters. These are the ones what you configured in the application properties, and the host at which this application is running on, and you got the time zone and start time. This is very important. If you wanted to know when this application started and the running time of this one, you can always depend on these two values. So they will provide information about when the SIP server started and what's the running time. There are a couple of situations where configuration server restarted and SIP server not getting new DN's registration information. So in those cases, actually you can see if you open config server log, you will see when it was restarted, and then you can see SIP server, what time it restarted. So if it is configuration server restarted recently and you are not getting new DN information, so that indicates there is a gap, or there is a communication gap between configuration server and the SIP server. So those times you can actually go through this and take necessary action. Mostly it's a restart of SIP server. So that's what you can do it by just going to the start time. And another one, yeah, HA role, always startup log, it will have backup, and after that it will become primary, and you will see primary change from the next log level. Now next log file onwards. Now this file, this is also very important one. This is the first log file, and it will increment 1, 2, 3, 4. So it writes number of log files, and even if you have a storage problem, so number of you can say the complaint or the symptom maybe more number of logs are written in specified time. You can count basing on this one. You can see like there are some 40 log files created in 5 minutes time, and you can see what size of the log file. So those things you can capture from file number. Not only this, suppose if a single call is there for nearly some 30 minutes or like that, you need to follow, you need to have all the you got all type of files, and one file is missing. You will come to know by looking in the file number, so whether that file is available or not, or what happened there. And file number, it's a one of the important bit in investigation, deeper investigations. And next, drilling down in the SIP server log file, you will have all the applications which are which have SIP server application as connection. So those details are coming up here. Like you can see, interaction workspace, stat server, URS. We just added unnecessary applications also. Just I wanted to add something. So generic SIP server, generic server. So several servers are added to the. They have those applications have SIP server in their connection tab. Okay, and you got the log messages. It shows connected to configuration server, and redundancy type it will specify. Tenant details. So information is available all here. Then continuation to that, you have SIP server version details. Suppose if you forget, or if you wanted to know what version SIP server is, SIP server customer is using, you can find out from here. or from the next log files, the top line in the log file, the first line in the log file itself is going to be SIP server version. So you can find from there also. And then it will list out all the options which are configured. Not only configured, these are the options which were read by SIP server, and these are what it's going to keep in memory, and it will process the calls depending on the option value. Okay. Note that if any option is not selected, so it's going to write an error and it's going to print that information, such as here. If you see, following options are not used. So enable MSML media services false. So this option it is not using. So this is the only place where you will know whether SIP server actually read the option and it has taken that information into memory or not. That details you will get only from here. Okay. Otherwise, you will say, we may get information repeatedly that we changed some configuration, but still it's not working. So there are means during the startup time, this is the place where you can see that option has no effect. So it is not considering this option now, and if whatever the functionality given by this option, that is not provided by SIP server at this point. Now, similarly, after the T server options, it's going to give list of DNs which are configured in the SIP server. Then it shows the LCA layer. It's connected to LCA port number, and then it displays licenses, number of licenses it has, and it's going to print the listener details. And following that, you will receive a request register from several applications, other TLib clients. You will receive those requests, and accordingly SIP server is going to respond as per configuration. Just an important point, we got multi-thread logging. If you have a multi-threaded feature, if you enable, even the log level logging also written in separate files. So that information in detail covered in Tech Tutorial 76. Which is talking about multi-threading with SIP server. There they explained about the multi-threading and then how to read the log files. Next is 1PCC and 3PCC calls. This is most of the time SIP server, either it receives a 1PCC call or it receives a 3PCC call, and it's going to start processing the call based on DN options as well as application options. 1PCC, it's a first-party call control. It's a device, any SIP device like a media gateway or an endpoint, SIP endpoint or SPC sends an invite to initiate a new call, and taking that invite, it's going to process the call. And if you have a 3PCC, third-party call control, this is when you got different requests you are getting from other TLib applications. It can be IWS, or it can be GAD, or it can be URS, or it can be OCS, and they are going to send the request. For example, we have many, and some of them are here. T-make call, T-make predictive call, T-route call, redirect call, initiate conference, transfer. These are 3PCC requests. When you are investigating any SIP server issue, first thing is you will try to see, is it a 1PCC or 3PCC. If it is a 3PCC request, you need to dig deeper into the DN options what they configured. Depending on the configuration on the DN, SIP server is going to initiate the SIP dialog, first invite, and exactly depending on that only it's going to forward several messages. Okay, and it the route to follow, everything it decides based on the DN level options. Okay, now let's move on further. When you receive a SIP invite or when you see a SIP message in SIP server log file, you need to identify the direction of the SIP message, whether it is the incoming one or it is the outgoing one, which SIP server is sending. Now, if you see here, any SIP message you see in the log file, you will have the time, so when it arrived, and you got it's a SIP transmission received or sent. If you see here, received, sending. SIP server received in some SIP message can be, I just put an example of invite, it can be anything. UDP protocol and the size of the packet, and then you got IP address from where you received the message. And similarly, if it is responding anything, you will see the time, sending, the protocol it used, number of bytes. This comes for deeper investigations, bytes. That's the time where you will decide instead of UDP you will use TCP transport. So these investigations, for them you need to understand how many bytes the packet it's sending out or taking inside. Okay. Now this is the IP address it is sending to. So SIP server sending the SIP message and SIP server received the SIP message. Next is when you see a T library message. Okay. For example, I have taken request root call. It's received from some 484. It got some ID here. You got URS81. Of course, by seeing this, we can understand the request is coming from URS. This is purely depends on the naming convention you used in your environment and the IP address and some number. When you see this line, what exactly, how to interpret them? This information you will see when a client is connected to SIP server. You will see a message similar to here, what given in this place. Now you can see a new client 484. This is the socket communication. It's a TCP, so socket communication will be there. 484 connected from so-and-so IP address. And connection details clearly gives socket number. It's a remote socket number 484. Remote host is 192.168.0.3 remote port. This is for the TCP layer. So this part is for the TCP layer. And for SIP server, it gets the application name, URS 81, it can be anything. And then it gives the authorization name is URS 81 and it's the sequential ID. So it's number 3, third number given to this client. So the next client will get 4 and next one will get 5. This is a hexadecimal number. This is where you will see this one. And when you see a message like some client disconnected, or when you got issues with the socket communications, you will see all the time this socket 484. You need to concentrate more on what happened at the socket level, and you may need to configure more debug level options. Now coming to TLib message request response. Note that every TLib message what we receive, our SIP server can send an event. So there are, we can say it as 2 type of TLib messages will be there. One is the request, second is the response, third one we'll keep it as distribute the events. Depending on the call, where the call is, it's going to send events to all the TLib clients. Now if you see request root call received from, same thing. And at this place, the main important point is every request, TLib request will have a reference ID, and when responding to the TLib client, SIP server or any T server, it's going to keep that reference ID in response, and you can clearly see here distributing response and message sent to the client as well as any other client. For example, if you take stat server here, it is sending this message even to stat server, another TLib client, because it's subscribed to get events for this TN 9001. Okay, so it sends to all the clients, but you will see distribute response, attribute reference ID. So if there is any problem, you will just make sure my request root call, it is arrived on this reference ID. So you will verify, is there any response on this reference ID? Okay. Or in other cases, it will send events, distribute event. You can see again distribute event. Again, you can see distribute event. So it's going to send events to the clients. Here event queued, then event route request, and then event diverted, and you may have different variety of TLib events which are generated. So those events is in the distribute event and it sends. And now here, if you can observe, there is no attribute reference ID in this, because it's an event and not a response. So you will have just the TLib mandatory attributes will be listed here, but you will not see any reference ID. So that's what distribute event. So it keeps sending call progress events to all the TLib clients which are registered for or which are subscribed to get information for that particular DN. Let's move on to the next one, tracking SIP and TLib messages. Okay, now lot of information we discussed till now. Let's if we see now in here what happens in the TLib log level, how to investigate. Now you receive an invite, I'll see the invite, and of course we know first it checks from header, and it checks for the contact header. Is the number is available or not? No, its number is not available. So it selects inbound trunk that is associated with the address 192.168.0.3. And here, for investigating any call flow, the first point is you need to make a note of the dialog identity, that's the call ID. So you have a call ID noted here that represents customer side, and this is SIP dialog 1. And you will have a notification in the log file mentioning that there is a new call created, and the connection ID of the call is so and so. Now, so points to note for troubleshooting: call arrived on the trunk DN or the extension DN, anything it can be, the DN from where you received the invite, and then the SIP dialog identification, it's the call ID, note it down, and then you got T library con ID. This is important. This is the unique identification at the T library level, and your entire call will have this TLib connection ID written. And beginning of the con ID can be seen as like this, and it's a tip. If you wanted to find out which log file shows the beginning of this particular con ID, you can use the search string connection ID, give a space, and just then type the con ID. When you run a search on multiple log files, you will come to know which particular log file contains the beginning, and similarly even end also. So you need to take that entire set of log files which are from beginning to end, and you need to investigate during troubleshooting. Yes, and the call progressing further, because it's meant for a root point. So you will see T library messages like event queued, and then you got event route request, and in between URS keeps sending updates, and the call routed to an agent. Now, of course, we know how it selects the destination DN. So the other DN is 2223. So it finds extension DN with that number, and it's going to, it needs to send an invite to this number. And in this example, 2223, it sends a register message. So I have the latest contact information for this DN. So it's sending a new invite to that contact address. And now here, note that call ID is completely different here, and this is representing SIP dialog 2. This is agent side. We got customer side and we got agent side, two SIP dialogues. And once the call is established, you got event established message. Again, points note, already noted down the con ID, you got the inbound details. Now the call went to extension 2223 and the second SIP dialog, this is the one, and you got media gateway details. The logical flow is represented as media gateway, SIP dialog 1. So this part is covered in SIP dialog 1, Genesis SIP server, and you got SIP dialog 2 towards agent endpoint. And later caller terminates the call. So we receive a buy message, and you can see the buy is coming from SIP dialog 1, and we received it. You can see we received a SIP message by terminating on SIP dialog 1. So as soon as we receive this buy message, SIP server is going to terminate the call, rest of the parties. So agent side SIP dialog, it terminates. Remember, because this is the representing customer side, so it as customer disconnected, it is disconnecting rest of the call IDs or rest of the SIP dialogues. And again, event released message will be generated on 2223. This is the DN. And similarly, event released, final event released will be there on the switch DN. So when you see this event release, this TLIB message, that indicates SIP server completely removed the call from its memory. So that's why you'll see distracted and you will see the con ID. So by any chance, if you receive any more requests on this particular con ID, it's very rare. Only in abnormal cases we receive requests even after the call release. At the time, it's going to send a event error saying that invalid connection ID. Okay, those messages you will see. So moving on to multi-site calls. So Genesis SIP server 1, you got one SIP server. This is single site, and now you may be having a second site with the Genesis SIP server, or you may be having some other T server connecting to a third party PBX. It can be IP PBX or it can be normal PBX. If we take the example of SIP server, you will have TLIB ISCC messages flowing in the T library, the TLIB protocol level, and you will have the SIP messages flowing between the SIP servers. Let's dig deeper into it. Suppose on source SIP server, I have two SIP servers in the multi-site environment. I mean, two sites are there. Agent customer call connected to site 1, that is the SIP server Mumbai, and that is acting as the source SIP server. And the agent who is on site 1, so he single step transferred call to destination, which is the Hyderabad SIP server. So in this case, any TLIB request, 3PCC request that is transferring a call to another site, it must have attribute location. So any 3PCC request that is meant for another site, it will have this attribute location. So attribute location giving Hyderabad switch. So SIP server is going to send a ISCC request to destination SIP server. It may be other T server, or it may be other T server, and that T server may be connecting to any type of PBX. But ISCC level, you will have very similar communication. So ISCC request, it's sent to that addresses server. Now remember, the tip is you will see send server to, this is the application name. You can see received from SIP server. So this is the T server application where you can actually find the source or the destination. So ISCC request, and request contains call data transfer type, and you will have the attribute reference ID, and you got of course our con ID. And again, this same information you will see here, and the SIP server on the destination side, SIP server Hyderabad, it's going to process this ISCC request and once it finds a proper resource, and here it is directory UI, so it's going to add the access resource and it is send to server, other T server, the source server with ISCC event call data transfer service details. And now here you can see. So the request is request get call data transfer service, and the response is ISCC event call data transfer service. And you will see the reference IDs matched everywhere. Same reference ID it will keep in all the requests and responses. So ISCC attribute reference ID, you got this one, and you got direct UI, you got the access resource details. So now, as we know, this is 040 and it is between two different SIP servers. For source SIP server, it's obviously going to be trunk DN it selects. So resulting request after ISCC request responses. So you will see request single step transfer, and now the other DN changed. It will have access code associated with the DN, and this SIP server, as it is not an internal number, it's going to find trunk DN to Hyderabad, and it sends the invite. And that invite received on the destination side, you can see invite we received, a new SIP dialog we received, and the trunk DN selected is to Mumbai. And that is having the IP address of source SIP server. And here you can see it's a logical flow. Media gateway, we got the first call is connected with SIP agent 2221 on this trunk, and this is connected to agent single step transfer call to agent in another SIP server. So you will see TLIB ISCC messages, they flow here, and then you got SIP dialog, and you can see you can count one SIP dialog between media gateway and Genesis SIP server Mumbai. Its incoming call is covered on inbound trunk, and agent connected to extension. And when he transferred the call, TLIB ISCC messages and a new SIP dialog created towards destination SIP server Hyderabad, and a new SIP dialog, another SIP dialog created connecting an extension 5551. And of course, the RTP always flows between the endpoints, between agent and customer. Now, this is the way you will have communication in multi-site. You can have 2 sites, or you can have many number, 3, 4, 5, 6, any number. And Tech Tutorial 55, this covers SIP call flying multi-site transfers. So how you can do that and how you can optimize trunks so that you will have better control on the call flow. Okay. So this is the way you need to understand the DN selection, DN options, and the application options, how they are configured. They are going to affect your call flow, and even in the investigating log files, you need to follow these guidelines, and you can troubleshoot any issues. Next is high availability. My colleague Oleg will present this one. Oleg, you can start.
Hello, everyone. Let me share my screen just a second. All right, I hope everybody can see my screen now. So just a few notes regarding high availability. First of all, why is it important? Obviously, SIP server is growing bigger and bigger, and as well as SIP voice communications, and we need to build up some reliability to the solution. Unfortunately, the problem is that SIP Cornerstone RFC 3261 hasn't provisioned any standard way for providing reliability to SIP solutions. That's why we currently have no standard way to provide HA, and this presents some difficulty for us. So let's see how we solve this issue. All right. So which types of HA we currently have within a SIP server? We have IP address takeover. Just a brief description of what it is. Let's say we have a SIP server which is running on one particular host and having certain IP address. On another host, we have a backup SIP server having different IP address. So we have an endpoint which would like to use high availability of those SIP servers. The problem is, according to SIP standard, endpoint can register only with one IP address. And we're having two at the moment because we have two SIP servers on different hosts. So the first most common solution is to have common virtual IP address which will be assigned as an alias to the network interface on the SIP server which is currently running as a primary. This works like a trick because we're trying to trick the network equipment into thinking that endpoint will be communicating to that virtual IP address, whereas the request actually will go to the actual SIP server application IP. This is most common implementation of HA, and this is the recommended way at the moment of implementing HA with the SIP server. The other way is using Windows Network Load Balancing. Previously, we recommended it as the main option for HA in Windows. Now we're trying to steer customers away from this technology because we've seen a number of issues with NLB clusters on Windows. The third way is a network-based HA, which has some drawbacks. What actually this method actually presents. With network-based HA, we have a special network equipment which acts as a special layer distributing requests between two SIP servers. So as transport layer is no longer responsibility of the SIP server. Obviously, the drawback of this scenario is that we need a special equipment for that. Normally, we would suggest using F5 local traffic manager. But having additional equipment means additional points of failure. You need engineer to service F5. You need additional service agreements, and so on and so forth. And the remaining method is SIP proxy, which is another software-based Genesis product, which is actually a simple SIP proxy application as defined in RFC. I'm not going to dig deep into this topic at the moment because SIP proxy is a product on its own, and it probably deserves a special TOI for that. So let's see what can go wrong actually with those HA implementations. Well, this is how IP takeover HA implementation look like. So we have a virtual IP address at the bottom, which is currently enabled on the primary SIP server host. And we have the same virtual IP address on the backup SIP server host, but at that particular moment, it is disabled. So by enabled and disabled, we understand that the network equipment will send the request with destination of virtual IP address to the host where this address is enabled at the moment. How it works? It actually is working on the network level using address resolution protocol when we binding the IP address to specific MAC address, so that network router would know where to send this request to. What potentially can go wrong in this scenario? Obviously, if we're working with IRP, apologies, seems I'm not changing the slides. Is it better now? Yeah, I think so. So what potentially can go wrong with the IP takeover scenario? As we rely on the IRP technology to let network know where to send the request to, if IRP cache is not updated on the network equipment, this way obviously would fail. So first of all, if we have any issues with IP takeover H8 implementation, we should check whether IRP cache is updated locally on the machine, whether the IRP cache is updated on the network equipment, and your network engineer probably would help you with that. Otherwise, you would need a Wireshark trace from the SIP servers, both primary and backup, and the endpoint equipment, which is having difficulties connecting to the primary SIP server. Alternatively, they can be, as in Windows, let's say we rely on netch command. We can have issues when netch is not responding for some reason, or takeover takes additional time, just because netch is not able to create a new alias for the network interface in the operating system. However, those cases are quite rare, and we haven't so many of those. The main issue is the IRP cache updates on the network equipment from our experience. Right, so we should proceed to the next one. The next one is the Windows NLB technology. Just a brief note why we are trying to steer customers away from this. The problem we've seen with NLB is the cluster itself is a product of Microsoft, and having additional product introduced into the infrastructure means additional maintenance requirements, and cluster on its own is quite complicated product. So we occasionally see issues. Apologies, it seems like we're still having issues with slides. We having issues with NLB when hosts in the cluster are not converged. It means that any attempt to perform a switchover of SIP servers would fail. We potentially could see an issues with NLB when one of the interfaces stop responding for some reason. With a cluster, that would require manual intervention, like drain stop the interface and perform additional troubleshooting actions on the cluster itself. However, if we're having issues with SIP server, and on top of that we're adding issues with the interface, this might present certain difficulties if we're having like a production down situation. From experience, we also seen that the switchovers of SIP server on a cluster is not really an immediate action. So it might take a while until backup SIP server will take over and become primary and start serving the clients. So that's why we're trying to use the first method, IP takeover. All right. So now we're moving towards the device-based HA, in particular F5-based HA method. On this picture, you can see that. I hope you get a picture. You can see that in the middle between SIP server pair and the network equipment, there is an F5 box which is actually performs HA functions. It's pretty simple. F5 sends options to both SIP servers, and according to the response to those options messages, it knows which of SIP servers is currently active and respond to requests. And in this way, F5 would know where to send the request from client to. Let's say if SIP server stops responding to the options messages, F5 would consider the SIP server as down and start sending requests to the one which is still responding. Pretty straightforward. However, again, F5 is additional piece of equipment which should be purchased, maintained, updated, and obviously we still can have some issues with these technologies. In particular, we've seen problems when F5 was not configured correctly and was used only to traverse just the part of the network traffic, like only SIP traffic was passing through F5. And we cannot guarantee that HA solution would work in this scenario because we've tested so far only the configuration when all traffic goes via F5. And obviously, as F5 relies on the options messages, which is sending to check if the SIP server is alive, if any of those options messages are lost, F5 would consider SIP server as down. And obviously, it doesn't matter whether SIP server is actually up. And a message was lost due to the network problems between F5 and SIP server. Right, so let's move forward to the next one. Just a few useful options to consider when implementing HA. SIP server, starting from the release early 8.1 releases, actually has some built-in self-awareness, and SIP server can monitor its own virtual network interface, its own standard plib interface, its own SIP interface, and it has an ability to perform a switchover on its own without having SCS connected at all. So this is kind of unique for Genesis applications, because normally we would rely on the management layer to perform a switchover in case we experience some issues. But with that set of options you can see on the screen, SIP server can actually detect potential issues with the interfaces, and if any problems detected, like interfaces down or SIP server is not getting SIP traffic, it will initiate automatic switchover, and it will go to service unavailable state or will set it itself as a backup. let's say if we're not getting enough SIP messages. All right, so let's move to the next part of our presentation, SIP span. I guess Vish briefly mentioned on how can we match SIP and TLEAB logs because it's essential to keep track of the call in both threads. So starting from early 8.0 SIP servers, multi-threading was introduced to the SIP server application so that SIP server runs in different threads, and the SIP thread is separate from the main application thread. This brought us some unfortunate consequences because every thread generates its own log, and in order to track the call across those logs, we need some special tools. And one of those tools is SIP span, which allows you to match logs from different threads in SIP server. Let's see how it looks like. So let's say if we have standard output of the multi-threaded SIP server, it's 5 log files, and every of those log files contains just a little bit of information about the call or about the state of the SIP server at the particular moment. Obviously, it's not that convenient to track them manually by parsing every other log file. So with the SIP span, all those messages are merged together and presented as a beautiful call flow, which you probably can see on the screen at the moment, which combines both SIP traffic and TLEAB traffic. The drawbacks of the SIP span is that it doesn't offer good visual understanding of how call flow looks like if you're trying to parse a particular call. And unfortunately, SIP span doesn't help you when you need to parse the network traffic. And for the network traffic, we obviously will need to use a Wireshark as we usually recommend. Well, a little bit over time, so I guess this concludes my part of presentation, and I'll hand it over to Debbie. Thank you for attention.
Thank you, Oleg, and thank you, Vish, for an excellent presentation. And we just have a couple of reminders. In addition to these tech tutorials, Genesis provides troubleshooting workshops from Genesis University that may help you with troubleshooting SIP server and other products. Also, Genesis has made a huge effort to build knowledge in our knowledge base, and so you may be pleasantly surprised by the amount of information that you can find in our knowledge base, not just product manuals and release notes and these tech tutorials, but also answers to specific technical questions and solutions. Our next tech tutorial will be on upgrading to Framework 8.5, and it's scheduled for December 4. You can register using the link that you see on the screen here. And we'd like your feedback on this tech tutorial. As we mentioned at the beginning, when you exit today's tutorial, you'll be given a short survey to answer, and we thank you for your feedback. I believe that all of the questions have been answered in the questions chat window. So if anyone has another question now, please click the hand icon or type it into the chat. Otherwise, we will conclude today's broadcast. And it looks like we have answers to all of our questions. So I'd like to thank everyone for attending today's tech tutorial. We will now end the broadcast, and we hope to see you again at a future tutorial. Goodbye.